Dobre rano, Ostravo. I hope I pronounced this correctly, and I will stop here because I do not want to embarrass myself. That's my high peak when it comes to Czech. As I was introduced, I work at AWS. My name is Wojtek or Wojciech, and I actually come from Gliwice, Poland, like 80 kilometers from Ostrava, and that is actually my first time at the TechMeetup, so it's really nice. The title of the talk is very lengthy, but at the same time, you can expect that I will address the serverless as a technology thing, but it will be in more pragmatic, business-oriented way, because I would like to show you that even that we talk a lot about technology during the conferences, we learn a lot about the technology, we use it on a daily basis. Technology should be a servant for the business, and this is actually a real story for a real company that I participated with before even I joined AWS. And this is actually a pretty interesting example how technology can help when digital transformation and learning new skills and actually embracing cloud for companies that are not there yet or trying to be in cloud native space. You know a little bit about me. I would like to know a little bit more about you, so let's do a show of hands. How many of you are involved in the software development on a daily basis? Hands up. All of you, okay. How many of you are using cloud in production at the moment? Any cloud? Most of you. How many of you are using AWS? Okay, great. So even that I work at AWS and we will talk about serverless, this will be pretty cloud agnostic topic. I will not talk a lot about the vendor-specific stuff, but I will use AWS as an example because the story is about AWS, and I also know AWS the best because that's my specialization since the 15 years. I worked as a SysOp, as a software engineer and cloud architect for those years. I talked about the story, so let's start it. Everything starts in late 2019, before the pandemic. And before I joined AWS, one company that has headquarters in Gliwice actually reached out for help. I was a cloud architect in the company, and I was responsible to actually drive and help them throughout the journey. It was a pretty interesting company. They deliver productized solutions for loss prevention, and they are used by the retail companies and anything that is considered as a FMCG, so fast-moving consumer goods. And this is a pretty much product-oriented shop. So they are delivering stuff for B2B markets, but they are doing a lot of desktop stuff because they have a lot of legacy as well. Obviously, they are transforming themselves into the SaaS-based solution, but this is not the majority of their business. And that's why they invested into the cloud in the first place and start moving stuff into the AWS. This company uses a diverse set of technologies. On the one hand, they are having their own devices called the DVRs, the device video recorders. They are attaching themselves to existing CCTV networks and grab the camera images. They're doing a lot of C++, a lot of Windows development. But at the same time, they are doing as well a lot of cloud development because of the backend. And they are having .NET stuff, and they are having also Java, Python, and everything in between. Obviously, they are investing in video recognition and video processing. They are trying to embrace machine learning, so they are having a lot of Python because of that. And they actually faced an issue with the modernization effort because that motivation that they would like to be in cloud and move to the SaaS space, it scratched their monolithic itch because they have it in the system. Everything was built years ago as a monolith, and they started to actually redesign everything from scratch because it was unstable, very hard to scale, and actually required a lot of manual intervention when it comes to the updating the Windows services on those machines that are running and processing data. It was hard to maintain and deploy. At that point, deployment took like 3-4 weeks of work, which is, for a business that wants to move fast, it's unreliable and probably not sustainable in the long term. One great thing about this company is that they had a very young but talented team. And this was pretty interesting to observe how those people quickly caught up, even if they didn't have exposure to certain technologies. So for example, if they had a specialization in .NET, they pretty quickly caught up with .NET Core, even if they didn't use it in the first place. Additionally, they caught up pretty quickly when it comes to the cloud concepts and everything that was related to the cloud-native space. And I'm talking about cloud-native space, and that was tough for them because they completely skimmed over microservice era and containerization. Because if you think about how to move from monolith to cloud, obvious thing is lift and shift and move everything as is. Another thing is that you can redesign the monolith and create the microservices. But at the same time, if the company doesn't have an experience with microservice architectures, it's like splitting your problem into 10 new problems instead. So they basically said, no, thank you. We already have one problem. We don't want to have 10 other ones if we will move to microservice architecture in the cloud. Another thing, I said they skim over containers. And this is understandable if they are developed Windows-based desktop applications and the backend was in old school .NET. Why they should care about containers? They were pragmatic, they delivered software, it earned money. They basically didn't look into the flashy new things. And they didn't have any operational knowledge about containerization. And if you will think about how to move to the cloud-native space, obvious choice will be Kubernetes, everything that is related to that technology. But we cannot even start here because they do not have the basics. And another case is that maybe they can leave it as is. Maybe they can stay with this monolith, use it as they used pragmatically. The problem is that demand and the business growth is actually very rapidly increasing for them because they are seeing a lot of new inquiries. At the same time, 3-4 weeks of deployment time is something that is not sustainable for their business. So that's why they had to face this modernization effort. So we have eliminated a few options at the beginning, those 3 that I presented, but still we don't know how to tackle the issue, how to modernize their infrastructure. So we started the work with basically reconnaissance. We logged into the AWS account, and first things first, if you would like to know a lot about the new workload and you don't know anything about the AWS account, the first place when you should look is actually AWS billing, because you will learn a lot of things from that. Another stuff is to actually look into the IAM, because you don't pay for IAM, but at the same time, you need to know who has access to everything. And this is pretty interesting because you see that the bill as a total thing is like 7,500, and 90% of that is EC2, which already tells us a lot about the architecture and how it looks like. Billing is one thing, but how the application looked like in the first place. And that's not a misunderstanding. This orange processor is actually visualizing a huge, beefy EC2 machine that contains everything. You have there multiple databases, multiple Windows services, huge monolith deployed there, and everything stays in a one availability zone in US East 1. For those of you who worked in AWS, with AWS, this should scare you. You already know that this is not a great opportunity to have it, because you are putting all eggs in one basket, basically. You don't have reliability, you don't have high availability if something happens. And then we have those DVRs, data producers, on the left-hand side that are actually pushing data to something called input service. And we actually think that having this input service actually helped us to redesign everything from scratch. So we started with the pilot project execution, knowing the issues and the main pain points. They wanted to basically start to iteratively crush the monolithic application they have into smaller pieces, more reliable and more sustainable in terms of daily development. And we came up with this particular architecture as a pilot project. If you are feeling overwhelmed by colorful boxes, and probably you can see that from the end, don't worry, we will dive into this in details in a moment. But we left some of the stuff that was done by the legacy that is marked with those squiggly rectangles. So first things first, we left the data intake, the input service that we had, the gateway to the system actually, and then we left legacy databases for the pilot phase at least, because we didn't want to untangle everything that was built when it comes to the databases. Everything in between is actually split business logic from the monolith when it comes to data processing, data intake, that allowed them to actually make better integrations which were requested by the customers. Because, for example, if you are onboarding new retail network, you would like to process new types of transactions. And if you want to introduce it, you need to do it reliably in a few days instead of 3-4 weeks. And those colorful boxes that I presented you, if you are not familiar with AWS, most of that stuff, if not everything, if you will look, we actually left the legacy on the virtual machines, and everything in between is actually a serverless, something considered serverless on AWS. So why serverless in the first place, and why we actually use those services? Instead of using the hypothetical examples, I will refer to the story and the benefits that team observed. So first things first, they wanted to independently scale those elements. So they started with the serverless architecture in the first place to actually offload the scalability and operational side to the vendor, because they didn't want to spend much more time into setting up those virtual machines, setting up clusters that will run the business logic. Instead, they wanted to split the monolithic logic and move it somewhere else and host it somewhere else. And that should be someone else's problem how to host it. Another thing is that they observed a lower cost of development. So everything started with the deployment time, like 3-4 weeks when it comes to the preparing the packages, preparing releases, doing the actual release, and then firefighting the issues that happened after that release. And usually this took 3-4 weeks. At the same time, if you have multiple independent components, smaller ones, even that the overall thing looks much more complex, deployment of the individual pieces actually takes less time and it's more reliable because you are deploying smaller pieces. So after the 3 months onboarding 65% of the traffic, they observed reducing failure ratio by 80%. So they could reduce the time of the deployments, increase the frequency of those, at the same time reducing the failure ratio. And then, because they didn't have this in the first place, if you have a monolith, you are not, and this monolith actually causes a lot of problems, you are not investing enough energy and time and effort to build the continuous delivery pipelines and continuous integration, continuous deployments. And having those smaller pieces, they started to onboard real continuous delivery in the first place. So during the pilot phase, we actually spent additional time preparing CI/CD and the proper infrastructure as code instead of proper fighting with the scalability, thinking how to host those services on the classic services in the cloud, build the clusters, and so on and so on. So we could actually move that time when it comes to the investment from the spending time on the infrastructure to spend time more on the quality of the software and the whole delivery pipeline. And thanks to the serverless architecture and services, the team had more time to adopt those best practices for the software development lifecycle delivery. So instead of learning the classic services, they could embrace new tool chain and introduce interesting things. that were not present, for example, having the automated scans for the security of the dependencies that are used, and so on and so on. Why it was so important? If you will think about it and do a step back, nowadays, especially in the internet tech businesses, technology cuts the total cost of ownership tremendously. Like, if you would like to focus on the 2000s, if you would like to launch a startup, you need to have a significant investment at hand, because you need to buy everything, you need to build your own servers, server data centers with the servers, with the actual physical servers. Obviously, this changed over time. It became cheaper and cheaper over time. But eventually, maybe from 2011, 2014, you observed a lot less investment required at the beginning, especially with introducing platform as a service tools or serverless services available by the cloud vendor. And if you think about it, there were a few milestones available that decreased those costs. First one was introducing open source software and technologies, and then virtualization, popularization of that. Second one, around 2006, introducing of the cloud computing thing. It actually changed a lot when it comes to the delivery and how to build application. And then last but not least, we have the situation when developers are actually able to start companies with minimal investment up front. And having this, they are able to build even such companies that are able to compete with the huge enterprises with the minimal team and minimal investment. And if you will think about it, this chart actually shows you the landscape before the serverless become a thing for many vendors, because around 2014 it was available on AWS. So knowing why serverless is actually interesting, let's tackle the big elephant in the room and discuss what is serverless really. And I would like to start with a disclaimer, not mine, but someone who is very known in the serverless space, Jeremy Daly. Have you heard about the person? One of the general managers of the serverless.com, serverless framework. Anyone use serverless framework? A few. So basically he's saying that serverless is not about a technology, and it's not about being on the hype or delivering the stuff which is compliant with the buzzwords. It's actually, this quote actually is coming from the excellent essay, Stop Calling Everything Serverless, when he provides a pragmatic and very appealing interpretation of that term that I would like to present. The easiest way to start talking about serverless is obviously to talk about how we handle compute capabilities in the cloud. For many customers, that's their decision how they deploy their application and where deploy their application. So we can start on the bottom when you have the most thing to manage. You are doing the virtual machines, the classic EC2 instances. You are doing a lot of manual work, networking, everything is on you. Then you have middle ground with the more things, with things that are having and relying more on the cloud providers, on the vendors. Those stuff like Amazon ECS, managed Kubernetes, then additional services like AWS Fargate, anything relevant to your cloud provider as well. And last but not least, you have the serverless, which is the least effort required when it comes to management on your side, but at the same time, you have the most of the capabilities available to run your code. And when you're looking to optimize your time to market and pace of innovation, we always suggest to start with serverless, because this will allow you to manage as little as possible and focus on the actual outcome and the real business value you want to deliver. But talking about serverless only from the compute perspective is not fully understanding the picture, because if you will think about it, serverless services are available all across the stack. It's not about running your code, it's also about where you store your data and how those databases are scaling underneath. databases storage. You can also think about the integration between services and how those integrations are scaling with you. And Lambda offers many key advantages for the customers, and serverless compute actually offers that advantages. It's really where those components are actually integrated together, and where it means where they are actually shining, because they are giving you the bigger benefits. If you are trying to think about those integrations and additional elements, the effect of the synergy is actually kicking in and helping you build a better product. So messaging, orchestration, storage, databases, everything has a value that gives you the ability to actually offload the operational side and the operational complexity on the vendor, and you can focus on what's important for your business. And I'm talking constantly about the operation responsibilities because those are shared with your provider. Eventually, if you are using those more managed services or fully managed services, as we call them on AWS, you can actually rely on them and focus on what's really important for your business. And when it comes to this shared responsibility, you can see that most of the stuff that we used for this particular project was on the right-hand side, sorry, on the left-hand side, on my side, on your right-hand side. So on the spectrum that is more managed on the vendor side. Let's get back to the diagram that we had with our customers. Okay, something broke. Wait a second. It
doesn't stream or?
Yeah, it stopped streaming.
Let's try.
Okay, now it works, thank you. Sorry for this technical issue. So let's get back to the diagram that I shared. We left a few things that were built as a legacy, especially focusing on the databases side, because we didn't want it to untangle this in the first place. And then we left the intake, the entry point for the service, on the old EC2 instances, because we didn't want it to change the clients that were used and deployed in those locations that they are managing. On both ends, they made this as a deliberate decision to not tackle this in the first place, because it meant that we will be not able to actually catch up with the speed. Because we had 3 months for the pilot phase, and we wanted to deliver as much value when it comes to the deployment and reducing the failure ratio and reducing deployment time, instead of focusing on how to spend this time in the databases side. It doesn't mean that we left those things, because I will tell you in a moment how the project proceeded, but we started in this pilot phase with this. And then we used a lot of the serverless services. So starting from the left-hand side, we actually introduced the containers on the AWS Fargate that were additional layer. We call this an entry point 2.0, which was basically redirecting the old traffic to the old system and the new traffic that was rewritten to the new implementations for the data processing side that was implemented on the either Lambda or Fargate. You may ask, why did you choose 2 different compute engines for your business logic? Because it depended on the processing type. In terms of those transactions, we can process them as stateless workloads and stateless stream of transactions, or stateful stream of transactions. For those of you who work with Lambda, you probably know where I'm going with, but if you would like to learn and do a lot of the AWS Lambda, the first thing you will see in the recommendations is to actually think about the AWS Lambda implementation as something that is handling one event at a time, and do not share a lot of stateful stuff between invocations. That's why if we wanted to process those streams in a fully stateful way, we introduced AWS Fargate as a serverless containers. In between of those services, we actually have queuing mechanism, which is called SQS. And this allowed us to both process the messages depending on the processing type. Either if we had stateful processing types, we could use the first in, first out queues, or if we are not caring about the order, because there are some workloads like this, we could use the regular queues that offer higher scalability, but they are not guaranteed when it comes to the FIFO ordering. And then there was a last piece at the bottom that connects with the legacy databases, which is also implemented on the AWS Fargate. When we wrote our own writer, we called it a legacy database writer, to not overwhelm those existing legacy databases. Because if you think about it, the top part of the diagram is scaling automatically and independently. On the other hand, the databases are still on the old legacy infrastructure. So if we will scale independently the top part, the bottom part eventually may be overwhelmed. So we actually implemented a fail-safe and circuit breaker, whatever you will call it, mechanism in the form of the legacy writer that actually throttled those messages that were write to the database and then waited for applying everything in order, in a proper throughput. Additionally, on the left-hand side, we stored everything, all the transactions that went to Amazon S3 in the bucket, and we wanted to have ability to process those transactions, also querying those transactions to actually get the operational data and additional insight. And that was available with the help of the Amazon Athena and Amazon S3. Previously, those transactions landed in the databases in the Microsoft SQL Server. And as you can imagine, that required a lot of DBA expertise, how to properly optimize those tables, how to implement the cleaning mechanism of those tables. And this actually caused a lot of headache when it comes to stability. So instead, we moved everything to Amazon S3, and from that on, we shouldn't actually be worried about how scalable it is. And if you will think about the story that I presented, this actually represents something that you can call a leapfrog evolution. Because if you will think, most of the companies actually evolved over time, embracing every single step, one after another. So they started maybe with the physical data centers, and you also saw this as a paradigm shift on the compute. Company has the on-premises, the physical machines, then they want to move everything to the cloud with the help of the virtualization and lift and shift, cloud migrations, and so on. And those companies actually started with moving to the cloud. They moved to the cloud, they used virtual machines, they built the infrastructure and environments around that, but at the same time, they wanted to have more agility when it comes to spinning up and down those workloads. They wanted to use more functionality available in the cloud. They wanted to optimize the cost, and that's why they embraced additional services available by the provider. Sometimes it was related, for example, with the containerization, because that allowed many companies to consolidate workloads and spend less money on that. This also allowed to utilize better the existing resources available there. And then it started to change and affect the software development lifecycle, because it required the different techniques to actually embrace when it comes to software development. And then last but not least, you can jump into the serverless-like solutions or fully managed solutions like AWS Lambda, AWS Fargate, or anything relevant for your cloud provider. When you are actually building code and you let somebody else, in this case cloud provider, to worry about the infrastructure. And that's the end goal for this paradigm shift and evolution that some companies are trying to achieve. And instead of spending too much time on corralling infrastructure and not enough time on code, quality, application side, application architecture, you can actually focus on relevant stuff, embracing those. And either you can do it, as I said, in evolutionary way, step after step, gradually building things, or you can do a leapfrog jump, as this company in the story did. Because if you think about it, many companies start with the legacy architectures when they have the virtual machines available here on the left-hand side. Then they can move to the Kubernetes containerization. It's not easy, but it's possible to actually move it from that direction. It's very possible and very typical move. But at the same time, you can start with your EC2 and deploy your containers somewhere else. But in all cases, even if you'll go through your own solution and then you will move to the cloud, if you try to optimize the compute layer, the management, the operational complexities, you can actually jump directly to the fully managed solutions. And there are some customers that are skipping all of that effort, and they are moving from legacy architectures to fully managed serverless solutions. And my story is one of the examples, but this is not so uncommon thing to observe, even for those very traditional businesses, considered sometimes even as an enterprise IT, that they are re-architecturing their solutions straight to the serverless with this leapfrog adoption jump. It is possible, it can be done, and it's beneficial. And actually, with this story, there is one additional thing, a little twist. So we completed the pilot phase. We did a knowledge sharing session internally in the company, inside the organization. And one of the another teams responsible for video processing reached out to us, to our team, for help. So they wanted, this was pretty much a middle of pandemic, and they wanted to use their knowledge about CCTV cameras and systems and existing customer base to deliver something they called occupancy tracking support for COVID-19 limitations. So you can imagine a situation that you are entering a restaurant during the COVID pandemic, and there are limits in the restaurant, like, for example, only 20 people can be inside this particular place. They wanted to implement automated way to inform people based on the CCTV cameras if you can enter or not this particular location. This was a very time-sensitive business opportunity because they started very late in the process and they wanted to provide this solution to be viable for the customers. So they wanted to have a proof of concept going from R&D phase to production in 3 months. Then they have faced similar peopleware challenges as previously. So no experience with the cloud and AWS, no experience in terms of software development lifecycle best practices, especially in the cloud domain. So they needed to actually embrace those things very quickly if they wanted to deliver this with the help of the cloud. And they have totally different stack because it was not a .NET thing. It was more Java, Python, and video processing, computer vision, and also machine learning thing. So completely different skill set when it comes to those two elements. But we actually were able to help them. We started again with assumption that we do not want to waste time in this particular phases on building and scaling the infrastructure. We want to offload as much as we can to the provider. So we started with the ability to present and consume the video processing streams with the help of the service called Kinesis Video Streams. This allows you to consume the video feed from the devices with the help, for example, of the GStreamer, if you know that particular solution. But anything that is video-like can be consumed by this service and stored as a stream. Then you need to have the transformation logic for this video stream. This was implemented on the container side with the help of the Java libraries that were developed by them. And then we deployed the occupancy tracking machine learning model that took the frame, counted the amount of people on this frame, and then reported it back to the business transformation logic component. Then we saved everything into the NoSQL database DynamoDB, which is also a serverless solution and scales up regarding our needs. And then we exposed a serverless API that was exposed to the kiosks in those locations and showed either the red or green, in simplification, information that you can enter or you shouldn't enter this place because it is at capacity. This was also exposed to the mobile apps, not just for the kiosks, but this was pretty much a REST API available. So what were the results of this phase? So we started with a very rapid time to market. We developed the solution and deployed it for first 200 locations in 36 days. So this was pretty impressive, especially taking into account the team didn't have any exposure about the AWS. Another thing is that from the additional 2 weeks that we spent after that, we could embrace additional, and on board actually, additional 5,000 locations. So we were able to go from R&D phase to production phase very rapidly. And it was possible mostly because of offloading the complexity on the provider side, on the vendor. And then those 200 locations gives you roughly 500, 600 video streams, which is a lot to process. And additional thing was related to those streams is that we had understandable pricing model, because the biggest challenge for this proof of concept and why it was introduced in the R&D phase was that business wouldn't be able to say clearly to the customers how much this will cost them if they want to implement this occupancy tracking. And relying on serverless, we were actually very able to calculate the precise cost per camera on location and then add the margin and everything that is related to the business. And actually salespeople could present very clear understanding how much you will pay for your locations and what is the actual cost and why it actually costs as much. And since the D0, we were able to do this because we offloaded everything on the provider, and as a benefit, we received pay-as-you-go model, when you are actually able to calculate everything based on the consumption. And again, emphasizing one additional thing, standing on the shoulder of the giants, by giants I mean hyperscalers, cloud vendors, enabled you very extremely fast time to delivery, time to market, and we were able to focus fully on the business and transformation logic for this project, which was the most important thing. And at this point, they are actually onboarding new locations, and they shifted this particular solution from the occupancy tracking to actually quality tracking when it comes to queue management in those locations. So you can imagine that you are standing in the fast food restauration and you would like to order some stuff, but you wait in a very long queue. And they were able to pivot this particular project into that solution pretty easily as well. Wrapping up my story, I would like to emphasize on 2 key points. So my distinguished colleague from AWS had a very interesting essay about how cloud changed the creation of the applications. And I really like this quote because if you think about the internet, which democratized the access to the information, cloud computing actually democratized the creation of those applications. And if you think about those fully managed services, serverless in this case, it actually provides you a lot of benefits and a lot of power. So you are able to deliver much better stuff than, for example, we could do 15 years ago. And as a builder that started my career like 17 years ago, I can remember how hard it was to build certain stuff and how easy it is actually today to build similar things. And you may even say that if you will use the cloud, only sky is the limit, but this sounds like a cliche, and I will stop here. And this is pretty interesting quote, and I love it because it's so pragmatic. Previous one was inspirational, this one is again pragmatic. If you are a skeptic in the audience and you are also a very pragmatic person, you may ask, okay, but yeah, we can deliver that stuff if you have operational experience in our company, and then we will be able to leverage everything without the vendor. Which may be true, but at the same time, Sebastian, one of the team members, who was very frequently a third-tier on-call engineer, told this particular quote after we embraced the new approach for the first system, after we moved the 65% of the traffic after 3 months. He said that the serverless technology is optimized for my sleep, basically. He liked that so much that he could focus on actually business logic and delivering the impact, not on firefighting, that he expressed this during the retro and during the knowledge sharing that I mentioned. And if you are not convinced and still skeptical about this personal story, there are similar praises for multiple other businesses. This is from the Fender, but there are multiple businesses like Lego, Coca-Cola, Nike, which invested in having serverless architectures because they don't want to worry about the infrastructure. They want to focus on the business operations and everything that brings those businesses money. That's everything what I prepared. Thank you for your attention. If you would like to leave me the feedback, please scan the QR code. There's a survey at the end. You will be able to receive the presentation and additional materials. And you will receive, as a reward, AWS credits as well. And I'm available for Q&A. We can talk afterwards. We can talk now. Don't be shy. There are no bad questions. Thank you.
Thanks a lot. Meanwhile, we have already some questions. So basically, we can start with the first one from Tomáš Vítek, which has been voted as with 2 people.
Yeah, that's a good question. I haven't added this to the presentation. And as I said, initial price was around 7K USD. When it comes to the serverless solution, I cannot compare the whole quote because we still had those legacy databases and legacy data service at the beginning, but we reduced the number of machines from 30 to actually 15, so in half with the serverless approach. And then that gave us the less on the bill by 2.5K USD. So immediately after the pilot project phase, we were able to slice the bill by 2.5K USD.
By the way, is there somebody directly in the room which want to ask something else which is not there yet? No one? Okay, so we will continue with the questions here. What are the negatives of the serverless design?
Yeah, obviously there are no silver bullets here as well. The negative is actually, I wouldn't call it a negative explicitly, but you need to be fully onboarded with the decisions and that you will invest in the particular ecosystem. Because if you will use those services, you will actually do a deliberate decision that you are investing in that particular cloud vendor. It's not impossible to move out. It will be hard, but if you will make this decision on the diligent risk management, this would be pretty much an acceptable decision for many businesses. I would call this as a food for thought when it comes to using the serverless in this case. And another question is also great because what are the caveats on implementing first serverless projects? Definitely, if team has no exposure in the cloud, how to build those things, it has some learning curves. It is easier to actually build those things than learn Kubernetes, for example, but still there is a learning curve that is needed at the beginning, and I wouldn't be myself if I would know, if I wouldn't tell you that it wasn't for free, because for the first pilot project, we invested 3 months in the pilot project, and probably first 2-3 weeks, team learned how to use AWS CloudFormation, serverless application model, all those tools that are around those things, how to properly write for the AWS Lambda in .NET Core, and so on and so on. So that was a learning curve needed at the beginning. And how many devs worked for the projects presented? Yeah, so for the first one with the data processing side, we had a team of 4 developers splitting the monolith, .NET developers, and 1 tech lead. And tech lead was responsible as basically a software architect. And then for the capacity occupation tracking, we had 1 machine learning engineer that actually deployed an existing model on SageMaker. And then 2.5 Python engineer. And I say by half because that particular person was onboarded 50% of the time for the project. And it wasn't fully dedicated for that particular one.
So it seems that all the questions have been answered. Something what you have in your mind you want still to ask? Nothing. So thank you very much for coming up here.